Alright, man. Hopefully I can pull this off. It's been a while since I've done actual math. But if we're looking at cosine theta plus I sine theta. So two things to recognize. Here, I'll call that f of x. Recognize if we multiply both sides by I, then I would end up with I cosine theta. And then since I would multiply I by I, that'd be I squared, so that's a negative 1. So it'd be minus sine theta. Cool? However, and I said x, it should be theta. Sorry. Here, let's erase that and that. However, if we take the derivative of our original function, so if we take the derivative of cosine, that's going to be negative sine of theta. And if we take the derivative of I sine theta, that's going to be I cosine theta. So, hopefully what you're recognizing, and I'll do this in like the bright red, is that this guy is equal to that guy. That's a big deal for us. That means that I keep saying f of x, that means that if I take my original function and I multiply it by I, that's the same as taking the derivative. So that's the first part. The second part is going to be recognizing that that's a general form of an equation. So now I'm just going to use g. So we'll say dg over dx is equal to I times g. So the derivative is equal to I times the parent. Okay. Now, get all of your variables on the same side, and you should get 1 over g dg equals I dx. Cool with that? I don't know. I'm waiting for you to respond. We'll then, and here I'll do this in a different color again for us. We'll then just integrate both sides. And when we do that, our integral of 1 over g dg, that'll come out to be the natural log of the absolute value of g. And then the integral over there is going to be I times x. And then we will have our constant over here as well. That's the second part. The third part is then taking both sides. So here, let me just rewrite that. So we have absolute of g is equal to ix plus c. I want to raise both sides by e. A, to get rid of that natural log. B, because I want to get it into the form of the equation that you presented. So, raise both sides by e. This will just leave me natural log of g. This will leave me e to the ix plus e to the c, which, no wait, sorry. What do I want to do here? I want to erase. So that's e to the ix plus c. But I can take anything that's added in that upper part, and that can become multiplied together. So e to the c multiplied by e to the ix. Then that e to the c will just be its own constant. Um, and then I can also take the absolute value out as its own constant as well. So I'll end up with this g equals some sort of constant, e to the ix. So we've now taken that uh, first specific equation, and then we've shown that it fits this general form of an equation. So now we just need to determine what's the value of our constant that makes this work. And if you set x equal to 0, you will see that everything pops out and it should be good. If you need help with that last part, let me know as well. Well, here, I'll just show you real quick. It's not that big of a deal. So we take our first equation. So we had our cosine, and then I'm going to evaluate it at 0 plus I sine at 0. We can see that that equals 1. And so now we want to say, hey, so e to the I times 0, that's just going to equal that constant. So QED, that means our constant is equal to 1. Therefore, our whole equation at the beginning, cosine theta plus I sine theta, wow, that was a bad one, equals e to the I theta. So, hope that helps you, man. Good luck.